There we go. All
All
right.
right. Okay.
If you don't mind, you can start from the beginning. I mean, I think we're one slide in, but if you like.
Okay. Okay. Let me share screen. Oh, let me pick the right screen. Okay. Here we go. Okay. So I'm going to present about a robot I made to feed my pet rabbit, Clover. Clover is a very cute little bunny who deserves to be fed on a very reliable schedule. So this video is going to show you a demonstration of the robot functioning, and hopefully there'll be sound. Hopefully hearing this sound doesn't confuse my rabbit. There we go. So next there should be sound where I'll describe the parts. Clover knows the sound and runs over here immediately. So these balls have a little opening where you pour in the pellet food and then it slowly lets it out as Clover plays with it. And here's the motor that turns these two plates. Here's what the pellet food looks like. It falls out of the balls a little bit. Then there's this tube here that the balls come in. So this is where I put the full balls the day before. And then this opening slides through first. So this slides in this direction. So it allows one ball, you can see the ball there, into this chamber. And as the discs continue turning, eventually this opening comes around and then that allows the ball to fall down. So these two discs are locked together. It only has one moving part, just this motor. So these discs move together as a unit, kind of like a spool. Yeah, this is just to hold the other end of the central in there, just a little ball bearing so it slides nice. Up here I have my holder for my little Arduino here. So this is just a 3D printed pocket to hold it. Here's my Arduino. It's got the current time and military time, and then it's gonna dispense a ball at 17:30 and at 21:30. So that's 5:30 p.m. and 9:30 p.m. That's when Clover expects her balls. This little dangly doodad here is a real-time clock, so that keeps track of the time, you know, even if there's power outages and that sort of thing, or if I unplug it or replug it. These buttons here allow me to manually activate it if I want to. I can also have it turn just a little bit if need be to get it aligned. I'm not gonna do a full manual dispense, that's that green button, because it will actually drop another ball and Clover will get super excited and eat all of her food too quickly. Underneath here, so the bottom layer is the actual Arduino computer. The one in the middle is a little motor shield that makes it easy, that comes from Adafruit.com, and it makes it easy to plug in your motor and to have two different power supplies. That turned out to be important because this thing was smoking on me when I tried to be lazy and just use one power supply. So yeah, there we go. I did have to try a couple different motors till I found one that worked well enough. It does have to have some level of strength because it has to push up the other balls when it kind of cuts through in between them. But I think it's working pretty well right now. Clover likes it. Oh, here she's cleaning up all the little fallen pellets now. Because this way she gets her food absolutely on time, even if I'm out and about or not here or whatever. So, you like it, Clover? Yes. Okay, so there it is. Here's these little balls that hold the pellets. This is how Clover's been getting her pellet food for many years now. So the only part that's new is them getting dispensed by this little robot. What's kind of amazing is I did swap out the motor, but this whole thing came together in just a few days. I was trying to like hack it together quickly so that even though I, of course, have a pet sitter when I go out of town, over Christmas, I wanted Clover to be fed at these multiple times a day. And like, you can't make your pet sitter spend the entire day at your house. So I was trying to like get this thing going together pretty fast before I was going to be out of town, and it more or less worked. You know, it's not completely flawless still, but I'm kind of impressed that it worked as well as it did on what is nearly the first iteration. The only really significant change I've made was I put in a little bit of a more powerful motor. Because I put this, I mocked it out in Adobe Illustrator because I mock out everything in Adobe Illustrator. I took the shapes I drew in there, exported them as SVGs that I brought into OpenSCAD to make 3D. This was a world record for me where I had 3 printers going at once at Sector for these. So that's part of the reason it only took a couple days to go together. I felt pretty cool having so many going at once. So that's why they're completely random colors too, because I don't know how to change the filament, but it worked. They all worked on the first print. And I just melted in some little bolts into the back of this so that my motor could be mounted securely in this part. And it seems to be working really well. I did, my 3D printed design had a little divot to help it line up right. So that seemed to work pretty well. Of course, there had to be laser cutting. The wooden discs are laser cut. This, if I make an improvement to this robot, it's going to be to fix these wooden discs. As you can actually see in this video of cutting it, this wood is so warped because I store my wood poorly, which Chris reminds me constantly. So these discs are so far from being flat, but they're stiff in a warped position. So this does not help me at all. So that would be the biggest improvement I could make, would be genuinely flat discs. Maybe metal would be nice because they would be thin. So maybe I'll look at doing that. That would be my next thing to improve this, because it works pretty darn well. Every now and then I'll try to adjust the disc height, and because they are not flat, they can be so tight that they trap the ball between them and then can't spin freely. So yeah, so I had to order all these parts. Still amazing that they all basically worked on the first go, and I had to cobble together a program. So my friend Becca helped me. We did some like drunk programming. That was fun. And Chris was the person who taught me what an Arduino is years ago. And for a lot of this, I copied a program that Brian had helped me with. So I would like to thank all of them for their help.
Questions?
Oh, Chris, nobody would want to buy this on eBay because it's so specific, right? Like, not only would you'd have to be wanting to feed a pet rabbit out of plastic balls. Like, it's not that common. It's a very niche item.
Did they make rabbit? Automated rabbit feeders?
Wait, what? For
Did
kids, we're gonna.
Automated rabbit feeders? Is that a thing?
No, cat feeders. They do,
That's
you
what I
know.
thought. So nobody sells a rabbit feeder.
Well, this is maybe a hole in the market. Maybe you're right. I did have my good friend Amy, who has pet rabbits. I think she's already expressed interest in it. So I think, Clover is a very senior rabbit. When she does eventually pass on, I think I will this to my friend Amy. But I don't know, like, it's not that, like, right now the times are like hard coded in there. Like, I'm not sure Amy really knows what she's getting into, but I don't know.
Sounds like your rabbits can adapt to the new schedule.
Yeah, that's that. There you go.
So, Kate, I have to say you successfully. I had no idea you were building such a thing. So nice work running under the radar. I had no clue.
Ooh. Well, blame yourself for teaching me too well, Chris. I did ask Brian for some advice, so I didn't do it completely in a vacuum.
I had no idea you used the real-time clock.
Oh, really? Yeah, if I was doing it again, I would pay the extra $6 for the higher quality one. I thought losing a few seconds every day wouldn't be a big deal, but that adds up. So it actually dispenses at 5:20 and 9:20 now. I've lost 10 minutes since I built this thing. So.
is that the crystal quality and the real-time clock? Like,
Yeah.
It's not very accurate, yeah. It turns out it needs to be crazy accurate to not lose time. So.
Yeah, I didn't appreciate that till now. So, I mean, Clover's liking it because it's losing time in the direction that means she gets it a little bit sooner every day. But
Do you adjust for daylight savings time, or do you let the rabbit live through daylight savings time, unlike the humans?
you know, I only put this together on like December 10th or something, so I have not had to face that challenge yet. But she sits next to this robot. Oh, by the way, she has transferred her love to the robot too. She sits by this robot starting at around 4:30 to 5 most days. So when we hit spring daylight savings, I will plug it back into my computer and adjust the time, because it would just be torture to like leave her sitting there now that she's so regimented. So
Gotta make it beep like sometime in advance, then she learns like the time of the difference between the beeps, and I'm just saying you could do something. Rabbit would know time pretty soon. It'd be good.
I mean, she knows, just for the record, she definitely knows time already. But yeah, maybe we could start teaching her more sophisticated language with these beeps.
Are you going to take what you learned and build something similar for Janie?
Oh, I think maybe you're making the mistake of thinking that I care about Janie as much as I care about Clover. That's our cat, Janie. I mean, she's good, but I don't know. It'd probably actually be to my benefit, because the cat is much more irritating when she's hungry. But I don't know. She eats wet food, so it'd be a whole nother thing. I'm already picturing like a screw going through gross wet cat food. It's going to be really disgusting. But yeah.
One of those old Spritz cookie makers.
Oh, how do those work?
My wife has one that's just like a little motorized kind of piston, and then it just kind of squirts out, cookie dough.
It sounds a lot grosser if you think of it than with cat food, but yeah.
All right. Well, thank you, Kate. I'm gonna try to do a talk here. So I'm gonna mute my.
All right, can everybody hear me on here? Yep. So 1 second, I gotta kill. All right, so this should work now. Everybody still hear me? Probably. All
Yes, we hear you.
Cool, thanks, Kate. So I've got that going up there. Let me share the other screen here. So I'm going to share the laser cutter screen, keep my audio, and that should work up there. Here we go. Okay, so then let me turn this on. And I think I want to flip that. There we go. All right, so you guys can see my video and you can see my screen. Actually, you can see my video on the screen. So we got a laser cutter donated from a Chinese manufacturer who asked on Reddit and the laser cutting subreddit if anyone wanted a laser cutter to evaluate or test. And so it's a ultraviolet laser. And so I had said that sure, we would test one. The only requirement was that I needed to be able to acknowledge that it got donated, and that's why we had it and why we can test it. So it's this little box here. So it's basically just a little 400 millimeter by 400 millimeter gantry, and then it's got an ultraviolet 5-watt laser module on there, which you can see if you look at the screen there, the little video. And what we did is it comes with a really small shield. It's actually magneted on. It's this little thing. So it's a little chunk of plastic, and this plastic is supposed to block the ultraviolet frequency of light so that you don't get blinded. And then they also give you this pair of green safety goggles. And supposedly, it's supposed to keep your eyes safe. In reality, though, you need both of these things on, like the combination of the red and the green, in order for you to keep your eyes safe. So long story short, I didn't really think that was a great plan. So I bought a $16 chunk of UV absorbing acrylic. And so we have a box now inside of the big laser cutter that the little laser cutter can run in, so that it doesn't kill us with the ultraviolet light, and it also keeps the smoke going away from us. So the reason that I wanted to show this is actually not so much the laser, but also, so I'm up on the computer now, and this software is called Lightburn. We got Lightburn a while back, and it's the first time I've used it with a different laser. So it's actually pretty clever software. This thing can support both using the big laser cutter on here, but I can also swap to the little laser cutter, and I can move between different jobs without really any effort at all. So it's pretty wild that this software is able to do this stuff. But we can go on here and we can run this smaller laser cutter. It's an interesting laser. It basically does everything that the CO2 laser does. And if you didn't have a CO2 laser, this would be a really cool machine. It's about $450, which is pretty inexpensive, all things considered. Or sorry, $250, pretty inexpensive, all things considered. And it does a surprisingly good job cutting things out. So I'm gonna basically trace this real quick. Hang on a second. And then I can show you the hang on. This is conveniently warning me that I'm trying to destroy the machine. Oh, we might have our first bug. Let's see here, hang on. All right, let me try this one more time. If not, we'll give up. It's been sitting here for quite a while, so I'm not surprised if it, oh, there we go. It wanted a reboot apparently. So I think it lost the serial connection at some point. Anyway, I was just gonna show what the thing looks like when it's running. So let me get over here. We can kill this. Let me go back to the video here. We'll set this up here. And let me jog this back over then. So as far as things this can cut, it can do all of the same things that the CO2 laser can, in that you can do wood, plastic, you can engrave like anodized aluminum. This thing should be able to cut stainless steel a little bit better, but we'll have to see if that's actually the case. I haven't gotten that far yet. Let me just run. I'm just gonna set this thing up to make a cut here. It's unsurprisingly really slow compared to the giant laser. So let me hit start and see what happens. So you can see how bright this looks behind the glass. Let me put the phone underneath the glass and start again. You can see how much brighter it is underneath the phone, and that's behind the like safety shield. It is super duper bright. So if you do end up buying one of these, you really do need to buy a better chunk of glass to protect your eyes. The danger of this laser is that it's because it's visible light, the visible light can go through glass, which means it goes through glasses and goes through eyeballs. And so it'll burn the back of your eye instead of the front of your eye, which is really dangerous. So in short, you can engrave stuff, you can cut stuff. This is really thin material, and it takes a whole bunch of passes to cut even really thin stuff. So this is not a super fast machine, but again, the difference in cost is pretty worthwhile. The bad thing is that in terms of, you can buy a K40, like a CO2 laser, and they are like $200 more expensive. So they're not super affordably cheaper than this necessarily is. So we get Brian apparently returning his hydroponic system to the store. Anyway, let me kill my video here. One second. So I'm gonna kill my phone and I'll bring back up the audio.
I gotta turn that. All right, so we should be back to normal. Everybody hear me still? And let me look at what the chat is. Yeah, so Dennis, as far as Aerosis goes, it's really clever. That laser has a fan at the top that cools the laser module, but it also cools the or it blows air down into the the other screen here. I just gotta share my other screen so that way they can see it here as well as. There we go. So what this thing does is they have a module in here, and what this has is right at the top is a big fan. It's blowing air down through the laser diode, and then it blows air through this guard. And the guard's actually cleverly designed. There's a cone here that's blowing air out, and so it's keeping the optics from getting dirty. It's got a bypass vent here to make sure that enough air is flowing, and then it essentially shuttles the air out the back away from the diode. And it's a low pressure system, so you're not blowing high pressure air through it. You could supplement this. You could put an air compressor behind this, but it's got a pretty huge orifice. So you probably need to neck that down with something else to kind of give it a better jet. But I was really surprised. The cut was surprisingly clean. It didn't really leave a lot of soot behind. The advantage, I think, to the UV laser for cutting thick wood is that the CO2 laser gets absorbed into the char and heats the char. And I think the UV laser transmission and absorption spectrum is very different in that it's able to obliterate the char without losing a lot of heat into it. Like the char isn't able to radiate the heat as effectively as it is with infrared wavelength. So the UV laser seems to be able to cut cleaner than the CO2 laser does. But I want to try some paper and some other things to see. The quality of the controller is really bad. It's like a serial, it's called the Gerbil controller. It's kind of like an Arduino. So it's like a 3D printer controller running a laser. And it's really not fast enough to do really fast engraving pulses, like to do images and stuff. It's too slow for that. But I'd be curious to see if you put that laser onto our much fancier laser controller that runs the big laser cutter, if it wasn't able to do faster pulse modulation control. They tried doing some PDO engraving earlier and did a very bad job trying to regulate it really fast. But other than that, for cutting and for other things, I'm really pretty surprised for $250 it does a surprisingly good job. Aside from the concern about blinding yourself forever, if they gave a little bit better regards to both warning as well as guarding, it would be good, but it's going to add a ton to the cost. So I can see why they would do that. They also, I mean, frankly, they don't have a lot of US liability, so it makes sense as to why. Any other questions?
So,
yeah, go ahead.
are you saying UV lasers in general are better than the CO2 laser, or this one is in the sense of cutting thicker wood?
It should
Like
be a better wavelength to cut wood that's already been cut. So our CO2 laser is better in all ways because it's got so much power, it'll just cut through in one go, don't have to worry about it. But if you had to make a whole bunch of passes, as in having a small CO2 laser versus having a small UV laser,
Right,
the UV laser seems to work better because it can cut multiple passes without just burning the wood. At some point, the CO2 laser dumps a minimal amount of heat, but it hits the char and then it sinks into the wood and just chars the crap out of the wood. Versus the UV laser seems to be able to burn through the char and then keep a narrow focus so that it doesn't end up having this kind of fatter and fatter char and burn and smoke instead of the ends. So yes, in short, a big CO2 laser is way better, but if you're gonna have a tiny laser, a UV laser might be better. But again, I have to play with it some more to see. Any other questions from anybody? I think one of the biggest issues at home is you're gonna have people buy these and put them on their countertop and then not realize that everything that you burn is terrible for you. We're cheating and putting it in a fully evacuated enclosure, but that's totally not normal. All right, Chris. Chris, did you want to go next? I think that's it as far as I know.
Yeah, I can go. Yeah, let me share my screen. All right, everyone can see that. Yeah, so I'm taking an online class in embedded software development. So this is kind of a my day job is sort of web and backend kind of application development, and so I'm trying to kind of learn new skills. So as part of this class, my final project is to kind of make like a little embedded system. And so I chose to do a little desktop timer. So just real briefly, the idea behind this thing is that you can, work for a little bit, take a little break, and then repeat that. And this thing just kind of keeps track of like those breaks and those like periods where you're working. And yeah, oh yeah. So the name of this is just like the little tomato kind of egg timer that this guy originally used. So yeah, so the concept is certainly not new. There's all these, if you look around for them, there's all these different kind of desktop timers you can get that I like the idea where depending on how you have it oriented, it chooses like a different timing function. So there's some of these that are more like, keeping track of what tasks you do throughout the day. And, there's like a Bluetooth app that you can kind of total up what you worked on or, things like that. So I kind of wanted to go for something like that, but just design my own little variant on that. So I started out with this dev board, which is pretty beefy for what it is. There's lots of like wireless connectivity, which at least initially I'm not going to be able, or I'm not planning on using. I think down the line, I might want to try to cook up like a Bluetooth app that talks to this thing. So far, what I'm using is the accelerometer and the gyroscope in it. It's got little MEMS sensors in it. Yeah, so I kind of highlighted a couple of the things that I'm actually using in the hardware abstraction layer. So there's SPI, I2C, USB, like a serial connection, might use Bluetooth, and then mainly the gyro and the accelerometer. And yeah, oh yeah, and then I'm talking to a little LCD screen over SPI. So I'm kind of working on doing most of these things kind of bare metal, other than using kind of the manufacturer provided kind of library functions. Yeah, so the idea that this is supposed to work, just when you turn it on, it will either show a little splash screen or just kind of show the stats of what you've been doing. And then when you change the orientation of this timer, it'll start, counting down for one of these periods, either like a 25-minute, 15-minute, or 5-minute kind of time span. And then once it times out, it dumps back to the stats. Yeah, it's sort of the same thing as a table. Yeah, so kind of what I'm noodling on now is kind of what sort of enclosure to make. And so I made like a little foam board kind of paper prototype of this, but this is kind of what I'm thinking, that I want basically to kind of this triangular enclosure where it will sit on the edge. And depending on like which side is down, that's what kind of time it's going to count up. So, here's how that would be oriented. And then, you rotate it 60 degrees, and then it would be like timing for 5 minutes. And if you did it the other way, it would be 25. Yeah, and so I started to kind of put together some 3D 3D drawings of this. I'm just starting out in CAD, so yeah, I've kind of poked at this a couple of different ways. Initially, I thought that I wanted to show sort of an analog, like a fake analog dial on the LCD. And so that's why I have this little circular porthole, just that you would see sort of a kind of Pac-Man shape sort of gradually count down as the timer runs. So yeah, that's pretty much it. Just real brief. I'm spending most of my time like working on the software, and yeah, that's it.
Hey, but what was the cost of the board? Thereabouts.
I think that one was like 60 or so, but again, it's way beefier than what I need for this. And so I think when I figure out kind of how the prototype works, I think it might be kind of neat to try to redesign this as just like a really small little PCB that just has like an accelerometer and like a little kind of trimmed down microcontroller in it. Like I'm not gonna try to solder like this is like a 100 pin micro, so nothing like that.
I was actually fairly confident that you broke all of the laser box generators online, making a three-sided object. Because I was like, I've never seen one that's not a square. But no, indeed, you actually can make Maker Case, you can make a three-sided box. But ironically, the preview for a polygon-shaped box is actually five-sided. They don't even show the three-sided. So again, you might contemplate, jump straight to 5 or 6 just to make things extra complicated.
One thing on design, I don't know what tools you use, but if you're a coder, OpenSCAD might be a good thing to look at.
Yeah, I had tried, I had done some other things in, was the web-based Onshape, just because I was kind of familiar with that one. But yeah, that one's pretty appealing also. I like the idea of just kind of being able to like tweak the parameters.
Yeah, FreeCAD has gotten a lot better as well. So FreeCAD is literally FreeCAD. It's an open source CAD system. And I tried it like 10 years ago and it was atrocious. And, but we installed it recently. I mean, it made like G code for the machines and all sorts of crazy stuff.
Oh, cool.
And it works. It works much better on Linux though. So the guy I was helping was playing on Linux and I was trying to run it on Windows and I was trying to help him. And it was just crashing constantly. He's like, I've never had it crash once. And then we finally compared OSs and he had it on Linux and it worked really reliably. And I'm guessing the developers all develop on Linux. And so they're probably aware of half the Windows bugs. So anyway, if you do try it, do be aware that there might be some problems.
Oh yeah. Yeah, I might try that out.
So will you indicate which of the 3 states corresponds to which orientation on that flat face, like above the clock and to the 2 sides of the, like on the flat face?
Yeah, that's what I'm hoping, just to have little icons or little numbers or something like that. Just kind of, I don't know if you've ever seen those, like I imagine like those like D4, like D&D dice, where they have like the numbers, like sometimes they put it up at the top or sometimes they have it on like the bottom edge or something like that. So
all right.
If you let Kate do like rabbit piles and piles of rabbits to represent time, I imagine she'll do that for free.
Nice. I will. It's true.
cool. Yeah, that's all I got. Well, thanks.
So I think that's it as far as presentations go. There's not a board. Anybody else got anything they want to share? Well, thanks for coming. Hopeful at the turn down here in COVID cases. It's certainly been a nice precipitous drop lately, so I think that'll continue to look at the reproduction trends for the cases. So that's at least looking good moving forward. So that's a plus. And the college students all went back. We didn't see a massive spike. So anyway, I'm happy to see that news. Good to see everybody as always. Thanks for comments and stuff.